Hi everyone, my name is Mohammed Pili. Today we are going to start math course. Firstly, we will discuss SSC syllabus. We may say that O level, and then we'll do A level. Uh, we are going to start from indices. The first topic that we have to discuss is about index class. Let's start the class. This one is lecture number 1. We have Okay, first topic, indices. Let's define and why there is a need of indices. Basically, when we have a repetition in multiplication in times, like a same number is times by many times, like here we have a 2 times 2 times 2 and times 2 times 2. So we can write this one as the index form, that is 2 raised power 5. Here 5 is known as a index, or you can say that this one is a exponent, sometimes also known as a power. 5 represent the number of times, like the number is repeating, or the number is times. Here you can see 2 is repeating itself 5 times, so that's why. Like, it's a very simple, like we have a repetition in addition. If we have a repetition in addition, like we have a 5 plus 5 plus 5, um, instead of doing this addition, we prefer to do times. We have to times 3 with 5. Why with 3? Because 5 is repeating 3 times. That's why. And 5 is repeating. So that's why 3 times 5 will give you the same answer, 15. And this one will give you the same answer. It looks very easy. Like here, the question arises that why we are doing these things. Basically, the reason is that when we have a repetition many times, here we are only repetition of 2 times, 5 times. Like if the repetition is 20 times, or you may say that 30 times, then it will be very hard to calculate it manually. Like if I said that you have to add 5 20 times, so it will be a hard task. Even on calculator, it will be a hard task, and there are more chances of error. 5 plus 5 plus 5 plus 5, 5 plus 5. So you can do 20 times 5. Same debate we have in the indices. If a number is repeating itself many times, in multiplication. So you just have to write that in index form, and we can calculate directly by using the calculator. Yeah, you can see we have a calculator. Look here, if we just time this one 2 times 2 times 2 times 2 times 2. Here I just times this 2 5 times. So I'm getting the answer 32. So if no, if we take the power 2 raised power 5, 2 raised power 5, that is also the same 32. So the second method is easier and also time saving method, and there are less chance of error. Same debate here, even we are taking very small number, like if you said that you have to times 2 10 times, so that is a really hard task even on calculator. Like here 2 times 2 times 2 times, we did 3 times, 4, 5, 6, 7, 8, 9, and 10. We are getting 1024. So I will prefer the second method, in which we just have to write 2 raised power 10. That's it. We are getting the same answer. So that's why there is a need of indices, exponents, and power. So I hope you understand this reason why there is a need of exponents. Okay, next we have some laws, some rules for the indices. Indices is the plural of index. And here, let me define it in more detail. Like if we have a number 2 raised power 7, so here 7 is an index, sometimes known as exponent, sometimes known as a power. Some author name this one as power, some name this one as exponent, and some name as index. And here 2 is known as a base of the number. And we can also write this, and this form, this complete form is known as a index notation, because we are writing our number in index, in indices. So that's why this one is known as an index notation. Like if I have 32, This one is a basic number, basic number. We can write this one into factor form. How we can write this one into factor form? We just have to do simple prime factorization. You can use tree method. Maybe you learn in previous grades like 7, 8. So here we just have to factorize this one like in this way. So you will get 2, and again you just have to factorize this one with 2, 4. Again, factorize this one, 2, 2. So we can write 32 as a factor form, 2 times 2 times 2 times 2 times 2. So here you can see that we are doing the conversion from basic numeral to factor form. After that, we can also convert these factors into index form like 2 raised power 5. And same debate, we can go back in vice versa. Like if we want to change our index notation into basic numeral, how we have to change? Like if I said that you have to change this index number into basic numeral, how we can change it? You just have to write this 3 4 times, 3 times 3 times 3 times 3. So that is equal to 81. 3 times 3 will be 9. 9 times 3 will be 27. 27 times 3 will be 81. Or you can use another way like 3 times 3, 9. And this 3 times 3 will be 9. 9 times 9 will be 81. There are different ways of simplification. Okay, that's the basic concept of indices. Now we have to understand the index laws. Basically, we have a total 6 laws about the indices. The first law is about the multiplication of numbers. When we have two terms with same basis, like we have a 2 raised power 3 times 2 raised power 2. So you can directly write this one as 2 raised power 5. So from here, we can make a result, that is, whenever we have two terms in times in multiplication, just add their powers, but only when they have a same basis. If we have a 2 raised power 3 and 5 raised power 2, then we cannot add their powers. It's not possible because they don't have the same basis. This only applicable when we have a same basis and they are in time, so we just have to add their powers. You can also understand in this way, like what's the meaning of 2 raised power 3? It means that we have 2 times 2 times 2, 2 times 2 times 2. And this one can be written as 2 times 2. That's all. And in total, we can see this one can be written as 2 raised power 5. So that's the first index law, that is about the multiplication of terms when we have a same basis in the terms and they are in multiplication, they are in time. So just add their powers. The second rule is about the division of the terms. Like we have a two terms with same basis, 2 raised power 3 over 2 raised power 2. So you just have to do subtraction between the indices of the terms. Like here we have a same basis and they are in division. You can also write this one in this form, 2 raised power 3 divided by 2 raised power 2. So you can directly write this one 2 raised power 1. Why? Because 2 raised power 3 take away 2, that is equal to 2. 2 raised power 1, or you can ignore this power 1, so you can write only 2. If you didn't understand, you can understand in the other way, that is we have in the numerator 2 raised power 3. 2 raised power 3 means we have 2 times 2 times 2. And in the denominator, we have 2 times 2. So from here, we can do cancellation. These 2 will be cancelled out, only 2 will be left. So from here, we instead of doing this hard work, you can make a result, that is, you just have to do subtraction between the indices when the terms are in division with same basis, and always subtract the denominator power from the numerator. You cannot subtract numerator's power from denominator power. Okay. After that, we have the third index law. We will practice all these index laws here from the exercise. We will do questions. Okay, the third index law is about the double index. When we are getting double index, there are two ways to getting double index. Like the first way is that in that case, we have a bracket between the indices. So it means that you just have to times the number. the indices that we have here. So it can be written as 3 raised power 10. You just have to times the indices. If we have a 5 raised power 2 raised power 3, in that case, you just have to times this one again because we have a bracket between the indices. So 5 raised power 6, that will be sums up. And we can also, if they mention that you have to find this one into basic numeral, you can easily convert by using the calculator. Okay, next we have a fourth index law that is about the zero index. The first one is about multiplication of the terms. Second one is about division. The third one is about the double index. The fourth one is about the zero index. When we are getting the zero index, it doesn't matter what's the basis. If we have an index 0, so we just have to take that one is equal to 1. Like even if we have 100 raised power 0, even 1000 raised power 0, it doesn't matter what's the basis. If the index is 0, you just have to put is equal to 1. That's all. It doesn't matter what's the basis. If the index is 0, you just have to write, you have to put that term is equal to 1. That's all. And the last, the fifth index law is about the negative indices. Like if we have a raised power negative m, or you can say that if we have a 2 raised power negative 5, in that case, you just have to change its place. Like this one is in the numerator. We can clearly see that. Here you can mark its denominator 1. So you just have to change its place. If we take this one in the denominator, so its power sign will be changed. Like it will be 2 raised power 5. That's it. Same debate here. We have 1 over a raised power m. Even if we are getting a number in negative, or like 2 raised power negative 3 in the denominator, you can also make it positive. Or just change its place. So it will be 2 raised power 3. If we take this one in the denominator, its power sign, its exponential sign will be changed. So you can write in this way, and or you can simply write 2 raised power 3. Even if we take this one in the denominator, so again we have to change the sign. Like if we take this one in the denominator, so we are changing the place, so we also have to change the sign of the exponent. That's all. These are all the 5 rules we have about the index laws. There is also another, you can say that type of double index. Like if we have a 3 raised power 2, 3 with exponent 2 with exponent 3, what's the meaning of this one? It means that we have just ignore this one firstly. You just have to ignore these 3, just solve these 2 raised power 3. What's the meaning of 2 raised power 3? It means that we have 8, because 2 raised power 3 means 2 times 2 times 2. Here we don't have to do times these things. We just have to find it out by using the calculator or manually, like 2 times 2 times 2. That is 8. 2 times 2, 4. 4 2 times will be 8. So 3 raised power 8. Uh, that will be simple form. That's all. Okay, now let's practice the question from the exercise. Here we have a question. First question is about in this one, you just have to write this one into index form. So its index form will be 3 raised power 4. And here in this one, the index form of this one will be 2 raised power 3 times 7. That's all. And here, remember that if we have a square root can also be written as the index form, in the index form. Like we know that if we have a square root, so it means that we have 1 over 2. It's the inverse of square. It's the inverse of square. If we have a cube root, if we have 3 on the third, if we have 3 on the third, if there is nothing on the third, so it's very clear we have a 2 here. It's understood we have a 2. It means that we have a square root. If there is a 3 on the third, this one is known as third. If we have a 3 on the third, it means that we have a cube root. Its name is cube root, and its uh, index form is 1 over 3. If we have a fourth root means if we have 4 on the third, so it means that we have 2 raised power 1 over 4. That's all. Same debate here. Like here, firstly, let's change this one to 5 raised power 5 square root. So it means that we have 5 raised power 1 over 2, and whole power is 3. if we simplify this one further, so how we can simplify it further? So it means that we have 5 raised power 3 over 2. That's all. And this one, question number 8, can be written as 3 raised power 1 over 3. And this one is means we have 10 raised power 1 over 5. If you see this question, question number 6, in this question, what we have here, we have to write 1 over 2 raised power 2 and 3 raised power 3. That's all. Here we have to apply the index laws. You can see in the first one, question number 11, you can see we have the same basis and the terms are in multiplication are in time. So we just have to do addition of the power. So there's simple form will be equal to x raised power 7. That's all. And here y raised power will become 13. Same way here, like here we have to apply the second rule. The first two questions are about the first index law. This one related to the second index law, in which we have same basis of the terms, and but the terms are in division. So I told you that when the terms have the same basis and they are in division, you have to subtract the denominator's exponent from the numerator's exponent. That will become 0 raised power 4. Why 4? Because when we take away 3 from 7, so it will become 4. So 0 raised power 4 will be our answer in this situation. In this one, its answer will be 0 raised power 100. We just have to do the addition because they are here the terms have the same basis and they are in times. So we just have to add their powers. Question number 18. Let's skip few questions here. You can see question number 15 is also very similar. In question number 16 and 17, it's very easy also. Like here, we just have to do addition between their indices. So -3 plus -2. So whenever we are getting two signs together, it means that there is a times between the signs. So positive time negative will become negative. So -3, -2, we don't have to do subtraction here. Both have a same sign, so it means that we have to do addition. So their sum will be equal to -5. So e raised power -5 will be answer of question number 16. Okay, next we have a question number 18. In this one, it's very clear. We have w raised power 4 divided by w raised power -2. So it means that we just have to do subtraction between the indices of the terms that we have because they have a same basis and they are in division. So always, I told you that always subtract the denominator exponent from the numerator's exponent. So if we subtract, so 4 take away -2. So here again, we are getting two signs together. It means that we just have to times these signs. So negative times negative become positive. So 4 plus 2, that will be equal to 6. That's all. Okay, next we have having a space here to solve the question. Just give me a minute, please. Okay, now we have to skip few questions because these are very similar questions. Like up to question number 23. 19 is also very easy. You just have to add this power. So their sum will be equal to 1. 1 over 2 plus 1 over 2 will be 1. So its answer will be y. You can practice this question if you face any difficulty in the question. So you can ask the question in the comment section. I will answer in that minutes. Okay. And next we have okay, we didn't discuss this rule. This one is a separate rule here. You can see we have 2a raised power 3, and remember that here we have a bracket. Bracket means we have this 3. We have to apply this 3 on all the terms that we on all the things, all the terms that we have inside the bracket. So it will be applied on 2 as well as on 3 on A. So 2 raised power 8 will be equal to 2 raised power 3 and also 8 raised power 3. So it can be written as 8a cube. Why 8a cube? Because 2 raised power 3 means 2 times 2 times 2. That is 8. So that's why. Mostly student made a mistake. They just take cube only on A. They just wrote the answer 2a cube. That's not the correct answer. The reason is that here we have a bracket and uh 3 is on all the terms, not only on A. If 3 is only on A, so it will be written like this. Here we don't have the brackets. It doesn't mean we have to apply this 3 on 5 as well. This 3 is only on A. If we have a bracket like this, it means that this 2 is applied on 2 as well as on this X. And its answer will be equal to 2 raised power 2 and X raised will become 6. Why 6? Because when we apply 2 on it, so this power will be times 2 times 3 will be 6. That's why. So 4x 6 will be our answer in this case. Okay, you can easily solve 32 question number 32, 31, and because these are very easy. Similar, same debate we have. We just have to apply the second rule here. The second rule is about the division of the terms. So t raised power minus 3 divided by t, it means that we just have to take away this exponent from the denominator's exponent. So we just have to combine t, negative 3, take away negative 1. So that will be equal to t raised power negative 4. Instead of writing our answer in negative index, I will prefer to write in positive. So you also have to write your answer in positive index. Try to write always your answer in positive index. So we just have to take this one in the denominator, so it will become positive. That's all. 1 over t raised power 4 will be our answer. You can practice the remaining question, or you can practice this question from your book. Basically, mostly we have not similar questions, but the concept is same. The index laws are the same. Okay, we will do also the harder question related to this topic. Okay, here you can see next we have little bit harder question here. You can see. Let's start from question number 47. So in 47, firstly we have to apply the rule, the double index rule. That is, we just have to times these indices because here we have a brackets between them. So if we just times 2 with 1 over 2, what will be the answer? So if we times 2 with 1 over 2, so it's here we have to apply the fractions multiplication rule. That is, numerator will be times with denominator, denominators will be times with denominator. But the question is that we don't have the denominator here, so we can mark by ourselves because it's understood. If there is no denominator, we can consider 1. So 2 times 1 will be 2, 1 times 2 will be 2. So 2 over 2. Okay, so that is equal to 1. So it means that if we times these two values, these indices, so their answer will be 1. So we can write x raised power 1 over, you can ignore the 1. And same debate in the next one, if we times 1 over 3 with 3, its answer will be 1. Why? You can check in graph 1 over 3 times 1 over times 3, that will be 3 over 3 is equal to 1. Same debate like the previous one. Okay, next, what we have to do, you just have to subtract the exponents. You have to take away the exponent of the denominator from the exponent of the numerator. Why? Because we have the terms with same basis in division, so that's why. So it means that x raised power 1 take away this denominator's exponent, that is 1 also. So it will become 1 minus 1, 1 take away 1 is equal to 0. So when we have an exponent 0, we have a rule that is we have to write that 1 is equal to 1. That's all. Okay, next we have a 48 question. Question number 48. In this one, we just have to times, look here, and we have a constant values as well here. So constant will be times with constant. 7 times 3 means 21. And we have to deal these two terms separately. Look at these terms have same basis, so we just have to add their exponents. So negative 2 plus negative 1. 21 w raised power -2 take away 1, because we have a double sign, so it means that we just have to times these signs. So the answer will be 21 w raised power -3. We can consider this one as answer, but I will prefer to write my answer in positive index. So how we can convert this one into positive index? We just have to take this one in the denominator, so it will become positive. So w raised power 3. That's all. Next, we have this question. In this one, we just have to apply this for I told you that here. We also have a rule whenever we have two or more than two terms inside the bracket, and we have a power or exponent in combined form. So how we can separate? And remember that only we can separate when the terms are in multiplication or division. If the terms are in addition, we cannot separate the exponent. Like if we have a plus b whole square. So we cannot say that this one will be equal to a square plus b square. That's not true. Okay. Like, but if we have a ab whole square, so we can write this one is equal to a square b square. That's true. If we have terms in multiplication and they have a combined power, so we can separate their powers. But if the terms are in multiplication, even in addition, we cannot separate the combined power. Okay, here these terms are in multiplication 2 and so this 4 will be applied on 2 and as well as on n. So this one will be 4. And here you can see we have a 8 n raised power 0. So here we have to apply the uh, third index law, that is about 0 index. So whenever the index is 0, so we have to write that term is equal to 1. Here you don't have to write 81, and this n is in times with 8. So we just have to put this value in bracket. Bracket means in times. So 2 raised power 4, it means that that can be written as a 16, because 2 times 2 times 2 times 2 times 2, that is equal to 16. We just have to times 2 4 times. So 16 and 4 divided by 8. So if you have a confusion like how we have to solve, you can convert this division into fraction. Like we know that division means the fraction. They have the same meaning, division and fraction. So we can do cancellation here, simplification of fraction. I hope you already know simplification. Maybe you learned in the previous grades, in grade 6, 7, like that. Okay, here if we simplify this one, so it will be 2 raised 2 and raised power 4. That's all. I'm well, basically the thing is that I'm explaining these things in a hurry, or you means that uh, uh quickly. Like the reason is that this one is very basic topic of grade 8. Mostly we discuss in grade 8, so that's why this one is not a topic of all level, but we have to do revision as well. Okay, now question number 15. In this one, again we have very simple calculation here. We just have to do 4x raised power 3 over 2 divided by 2x raised power 1 over 2. So firstly, we have to do simplification with constants. So it's very clear both are divisible by 2. Just divide them. So their answer will be 2. And here, look, these terms are in division and they have the same basis. So we just have to subtract the exponent of the denominator from the exponent of the numerator. So x raised power 3 over 2 take away 1 over 2. Here we have a subtraction of fraction, so we have to apply the subtraction of fraction rule. Mostly student made a mistake, like if we have a 3 over 2, take away 1. Don't subtract directly, don't write 2 over 2. Why? Because these are here we have these are in fractions, so we have to apply the fractions rule here. So firstly, make the same denominator. That's the concept. We make the same denominator, then you have to do subtraction. Here we already have the same denominator because we have to take away 1 over 2 from 3 over 2. We already have the same denominator. Just combine the denominator and simplify the denominators. 3 minus 1 will be 2. So 2 over 2. That means that we have a 1. 2 over 2, that will be equal to 1. So it means that 2x raised power 1, or you can ignore this one. You can simply write 2 raised power 2x, consider as a 1. So that's all. I hope you understand these rules, the 4 rules, sorry, 5, 6 rules, or around about 6 rules we have in total about the indices. So if you have any question related to these rules, so you can ask the question in the comment section. Okay, next we have evaluate the following 3 raised power 2 times 3. This one is very easy. So you just have to evaluate you just have to write the exact answer. There are different way to simplify. Like you can say that 3 raised power 2 means we have 3 times 3, and this 3 means we have 3. So that is equal to 27. That will be our answer. Okay, let's solve it separately. This will mean like this. Like here we have a question. This one, we have to solve 3 raised power 2 means 3 times 3, or you can say that 3 raised power 2 means 9. You can also solve in this way. There are different way to solve it. So 9 times 3 means 27. 27 will be considered as our answer. 100 raised power 0. I told you the rule about the 0 index. Whenever the index is 0, it doesn't matter what's the basis. So this answer will be 1. And here we have a 3 raised power negative 2. We cannot simplify in this way. Firstly, we have to change its index into positive, or we can change its place. So it will be 3 raised power 2. We just have to take this one into the denominator, so its exponential sign will be changed. So 1 over 9 will be its answer. Now we have to solve this one. In this one, what we have to do, we have a double index, so we have to apply the fifth rule, that is about the double index. You just have to times these indices. So negative 1 times negative 2, that will be positive 2, because negative times negative become positive, and 2 1 time 2. After that, we have a 5 square. 5 square means 5 times 5. That means we have 25. That's all. Okay, and let's skip few questions here. Okay, and let's solve question number 5 as well, because I think we also discuss this row. Just give me a second, please. Let me paste here separately. Okay, here we have a question. 4 is power 1 over 2. So it means that we firstly have to factorize this one. 4 is power 1 over 2. Or write this 4 into index form, index notation. Or we can write this, do do factorization by using tree method. So 4 can be written as 2 cross 2, or you can say that 2 raised power 2, and its whole power is 1 over 2. Now you just have to simplify this one. So how we can simplify this? In this, we are getting double index here, so it means that we just have to times them. So it means that the answer will be 2. Why 2 raised by 1? Because when we get the multiplication of 2 with 1 over 2, there its answer will be 1. You don't have to times this 2 with this 2. Remember that mostly student made a mistake here, because this one is a fraction and this one is 2. Or you can also make this one as a fraction. Just put 1 in its denominator, then you can apply the fraction rule, that is numerator will be times with denominator and denominator will be times with denominator. So 2 times 1 will be 2, and the denominator will also be 2. So 2 over 2 will be 1. That's all. Same debate on this question number 6, 7. And let's solve the question number 8. In this one, you also have to do factorization of 8. So if we do factorization by using G method of 8, so 2, 4, then again we have to factorization of 4, that is 2, 2. We don't have to stop until we are not getting all the prime numbers here. So 8 can be written as 2 times 2 times 2. In index form, it can be written as 2 raised power 3. And on 8, we have a 1 over 3, so we can write 1 over 3 like this. So it means that we have these indices in times. So 3 times 1 over 3 will be 1. You can simplify if you are not getting it. You can ask the question in the comment, or you can directly contact me on my number. I will give you the number at the end of the class. Okay. Next, we have these questions are very similar, very easy. You can easily solve. Here we have a question number 41, 42, and 43. Let's discuss these questions. After this question, we will end the class. Tomorrow, we will check the more harder question related to this topic. Then we'll move on to the next topic. If you want to do a specific topic in the class, in this session, so you can also uh, recommend me in the comment section. Okay, 41, question number 41. So we have to solve this one. This one is in mixed number. So firstly, change this one into a simple fraction, improper fraction. So 11 times 9 will be 99, 99, 1. When we add 1 into 99, so it will be 100 over 9. And the whole power is negative 1 over 2. There are two ways to simplify this one. The direct way is that you just have to flip the fraction inside the bracket. So if you flip the fraction, so you just have to change the sign of the exponent that we have here. So its sign will become positive. If you flip the, if you flip it again, you again have to change the sign. So then we will get the same thing back. So after that, we have to apply this 1 over 2 on 9 as well as on 100. So firstly, let's write this one into factor form. So 9 can be written as 3 square and 100 can be written as 10 square. If we times 10 times 10, so it will be 100. So that's why after that, this 1 over 2 will be applied on 3 as well as on 10. So 3 square here, this one will be times with 2. 1 over 2 will be times with 2 as well as with this 2 of 10. So after that, we just have to times this one. Their answer will be equal to, oops, that one, yeah. Okay, 3 raised power 1 will left here because 2 times 1 over 2 will become 1 and same debate here. So 10 will be our answer. 3 over 10 will be our answer. 3 over 10. That will be our answer. That's all. Okay, question number 42 is also similar. You just have to flip. 44 is also similar. These questions are very easy. You just have to flip the fraction, then automatically you have to change the sign of the exponent that we have here. Okay, and let's solve question number 49 and 50. After this question, we will end the class. 49. In this one, we have a 25 raised power 3 over 2 and times 4 raised power 1 over 2. So same thing. Let's change this sign into this exponential sign into positive, convert this one, this negative sign into positive. How we can convert? You just have to take this one in the, you have to change its place. Take this one in the denominator, so its sign will be changed. So 25, let's do, at the meanwhile, we have to write this one into index form. So 25 can be written as 5 square because 5 times 5 is 25. And upon 25, we have 3 raised power 2. And same debate we have for 4. Just write this one into index form. So 2 raised power 2 is 4. 1 over 2 on it. And let's take this one in the denominator. So then it will become positive 9 raised power 1 over 2. If we take this one in the denominator, its power sign, its exponential sign will be changed. So now we just have to times these values. So 2 times 3 over 2. What's the answer? 2 times 3 over 2. I told you that you don't have to times this 2 with this 2. This 2 will only be times with 3. If you have a confusion, you can mark the 1 in its denominator, then it will be very clear. So you just have to times the denominator with the denominator, and denominator will be times with the denominator. 2 times 3 means 6. 6 over 2. That means we have 3. Now you just have to simplify it further. So 5 raised power 3 will be our answer here. And for this one, it will be equal to 2. And this one will be 3 square raised power 1 over 2. So because 9 can be written as 3 raised power 2. 1 over 2 on it, same debate. 5 raised power 3 means we have 125. 125 times 2 times, here this one will be 3. 3 2 times will be 6. And now we just have to times the 125 with 6. You can use mental math here. 6 times 100 will be 600, and after that we just have to times 25 with 6, that will be 150. So that answer will be 750. You can use calculator to times this one, or you can do mental math here. That's a trick. If we have a 125 times 100, so just break this one into a number, like we have 10, hundreds, thousand, like that number, like the number with zeros. Even you can break this one into 12, 120. So I will prefer to change this one into 125, then times both of them separately. It looks like it's lengthy, but if you understand this trick, so it's very easy to do multiplication. So 6 times 100 will be 600. If we times the 25 with 6, so that will be 150. And then we just have to do addition, so that will be 75. There is no need of calculator, so you can use mental math to solve this question. That's all. Okay, I think that's enough for today. We learned 4 index laws here. The first one is about the multiplication of the terms. Now, when the terms are in multiplication, their power will be added up. Remember that the terms must have the same basis, and they are in multiplication, their powers will be added up. If the terms have the same basis and they are in division, you just have to subtract the denominator's exponent from the numerator's exponent. And the third index law is about the double index. Like if we have a double index like this, we have a bracket between them. So it means that we just have to times the indices. And the fourth index law is about zero index law. It means that whenever we have the index 0, we just have to write that term is equal to 1. The fifth index lies about the negative indices. Negative index, if we are getting the negative index, even in the denominator, it doesn't matter, in the denominator or the numerator, just change its place. If we are getting negative index in the numerator, take that term in the denominator, then its sign will be changed. Its exponential sign will be changed. Same debate for the denominator. If we are getting negative index in the denominator, just take that term in the numerator, so then the sign of the index will be changed. Okay, you have to change. Okay, and there is another index law that is about uh, the combined index. You may say that if we have two or three more than two terms in multiplication, and they have a combined power, like we have a bracket on them, so it means that like have power is n, so it means that we have to apply this power on each term. This n will be applied on A, on B, as well as on C, on each term. Even if we have any sign inside, like negative sign, this exponent will also be applied on negative sign. Like if we are getting negative 5 raised power 2, it means that we just have to times negative 2 times. Negative time negative become positive, and 5 raised power 2 means it's 25. If we are getting negative 5 raised power 3, so its answer will be equal to negative 125. Why its answer will be negative 125? Because negative time negative, negative time negative, time negative become negative. So and 5 times 5 times 5 will be 125. So there is 3 is applied on negative as well as on 5. So from here we can conclude a result, that is whenever we have uh even exponent on the negative sign, so that will be changed into positive. If we have a odd index, odd power, odd exponent on a negative sign, it will stay negative. That's all. Okay, we will discuss further in next class. uh Goodbye. Take care. See you again in next class.